and we are now officially behind time. So moving on, now to a dialogue on Resilient PNT. This is being chaired and moderated by Dr. P.S.R. Srinivasa Sastry, Director DSP DRDO. The esteemed speakers for this session are Shri Manish A. Saxena, Director SATNAV-PO ISRO Headquarters, Dr. Roshan Srivastav, Project Director Technology Innovation Hub, Positioning and Precision Technologies, IIT Tirupati. Please bear with us a moment while we prepare the stage for the next panel. With that, I invite the esteemed chair and the esteemed speakers for this session, a dialogue on Resilient PNT, being led by Dr. P.S.R. Srinivasa Sastry. May I request you, sir, to please join us on stage. I request Shri Manish A. Saxena and Dr. Roshan Srivastav to please join us as well. Ladies and gentlemen, please remain seated. The tea will not be served. I assure you it will not be served before we officially declare a break. So there is no point in going outside. Might as well be here and be a part of this discussion. So with that, I hand it over to the esteemed chair. It's over to you, sir.
A very good evening to all of you. I take pleasure of introducing my panel with a brief biodata of them. Dr. Manish Saxena is the Director of Satellite Navigation Program Office at ISRO Headquarters, Bangalore. He leads the initiative for adoption of indigenous NAVIC system in various important national projects. He is working very closely with various government departments and industry experts in this regard. He also has contributed for the inclusion of NAVIC into national and international industry standards. He will be the best person to sit here for this Resilient PNT, and he is very knowledgeable about that. I think he will give very valuable inputs to us so that we can find out what industry can do in this very important field. Yeah, next I would like to read a brief about Roshan Srivastav, who is the faculty in the Department of Civil and Environmental Engineering at the IIT Tirupati, as well as Project Director of Technology Innovation Hub at IIT Tirupati. Actually, he has contributed his focus to drive translational research and promoted research to market activities and build an innovative ecosystem and created a skilled manpower in positioning and precision technologies under NMICPS. So I welcome both of you to this panel. So here we are going to have a dialogue on the Resilient PNT. We all know that PNT is very important, especially not only for the common man, but also for our defense services, which is very, very important. So in this regard, when we have to add resilience to that, that means in normal time, peacetime, everything works. But we have seen at the time of need, there are some people who can, kind of put a denial of that particular service, like what is happening. I also read in newspapers during this war. A lot of areas have been denied GPS services, and somebody is there to deny, somebody is there to help. That is okay. So, in providing, in this context, IRNSS constellation has been conceived some time ago, maybe more than a decade ago, and some of the satellites have been put into service, based on which NAVIC system has been developed. And we are also in DRDO, we have developed certain receivers for NAVIC, and we have given it to the services. And we are happy that services have indicated it is coming to a very good use for them, especially because it's indigenous, it is not easily deniable or something like that. So in this context, I would like to ask you, the total constellation is supposed to have 7 satellites. So we understand that we do not have all the 7 in place. How many are working, and with that, what kind of accuracy and what kind of service availability we have over, at least in the Indian region and across our board, around our border regions?
Yeah, right. As you rightly said, the constellation by design is a set of 7 satellites which are there in the geosynchronous orbit. As you know that the satellites, there have been a few non-functioning satellites, and few of the satellites also nearing end of their life. Currently the status is that 4 out of the 7 satellites are providing navigation service. Over the Indian region, even by the initial design itself, the system was designed such that it provides 2 sigma accuracy of 20 meters over India and 1500 kilometers. Today, because of the availability of 4 satellites, this 20 meters still is achievable within India. But at the edge of the coverage, as you know, there will be a few satellites may not be visible. In those cases, the accuracy may degrade. But for most purposes, within the mainland, the accuracy and the availability of our satellites is as good as what it was originally conceived for.
Yeah, it's very good. That's why our services are happy with the receivers what we made, and also the services what we are providing from space. Now, I would like to ask Dr. Roshan, in Tirupati, IIT Hyderabad, Tirupati, you are doing some kind of research activities in especially providing PNT, advancements in PNT technologies and things like that. Can you just tell what kind of advancements you are thinking to achieve, and what is the time frame of that?
Good evening. Thank you, sir. Good evening, everyone. First, I would like to put up a context like what is this Technology Innovation Hub at IIT Tirupati. There is something called National Mission on Interdisciplinary Cyber Physical Systems, in which Government of India has allocated about 3,600 crores to establish 25 technology innovation hubs across the country. Most of these hubs are with IITs, triple ITs, and BITS Pilani. So we have like divided this into 25 different verticals. And one of the vertical is at IIT Tirupati, which is on positioning and precision technologies. Now, the major 4 objectives of any of the hubs, when I'm talking about Tirupati, I'm also talking about the other 24 hubs. One is to look at technology development or translational research in positioning and precision technologies, which includes PNT. Here, what we do is we have been given like 100 crores funding from the Government of India to develop technologies in these areas. So we fund researchers across the country, individuals, industries, co-develop the products with the industries. Second, how do we cater for the manpower? There's a very nice scheme what we see today with NMICPS. We have human resource development. For example, if any industry would require, any startup would require in developing the product, we provide fellowships for UG, PG, PhD, in fact faculty fellowships also. And the good part is you can regionally pick up any student from any institute, will be able to provide funding to these students. The third most important point what I would like to bring out here is about startup ecosystem what we have. We are here to invest into the startup in positioning and precision technologies. In fact, the most important is in the PNT technologies, where we would like to see as much as youngsters, startups get funding to develop these products and make it more and more viable in the market. The fourth is, of course, international collaborations. When I say international collaborations, it is not just connecting with the experts, but we also would like to buy the IPs, bring the IPs from outside to India and give it to the industries and develop the product in India. So it's mostly on Atmanirbhar program. We are registered as a Section 8 company. Under this scheme, the most important point what we are looking at development is one of the aspect what we have started is atomic clocks, development of atomic clocks, focusing on NAVIC products, which requires a lot of research, lot of developments. So these are some of the areas, and the timelines we are looking from here 1 to 2 years. So this is what we expect. Thank you.
So, Dr. Manish, this NAVIC system, we are having a separate receiver and other things for the service of common people. We would like to see, we are very anxious to receive the same positioning services on our mobile sets. Recently, I heard maybe a year ago that any mobile set that is fabricated or supplied in India should also have a NAVIC receiver. But still we are not seeing. Can you tell us why and when we can have NAVIC services on commonly available all mobile phones?
Yeah. So, for the moment, we'll just look at the historical perspective in which the entire navigation systems worldwide started. And GPS has been the leader in this. And because of their powerful presence throughout the world, both geostrategically as well as commercially, the GPS system has been adopted by the industry on a mass scale over the past few decades. Till the time of the mid of the previous decade, around 2013-2014 time frame, a few of the other services also started to become operational. So even if we leave aside NAVIC, the other services like Galileo, they also had a lot of issues in trying to get adopted into the mass scale market. The simple reason being that any changes in this market, which is a very competitive one, even a few cents of implication on the devices really makes the manufacturers take a back seat, and they are not ready to adopt such things. NAVIC also actually emerged during that time frame, and hence we are also one of the people who are behind in time as far as the establishment of the system is concerned. So Galileo, NAVIC, all of us have shared the same set of struggle in trying to get into mass scale market. But slowly, as the devices have started emerging from the 3G domain to 4G domain, which calls for a change of the chipsets. So whenever a new design comes into picture, the designers look into what all are the available constellations, and in GNSS specifically, the more the merrier. And hence everybody tries to put in more of the GNSS systems. Earlier, because there was only GPS and GLONASS, people were not having that liberty. But since the mid of the previous decade, people started incorporating Galileo, as well as late of the previous decade, they started incorporating the NAVIC. Today, almost you can consider de facto in any phone that supports L1 plus L5, it will be having a NAVIC support definitely. And over the future, when we are going to introduce the L1 signal, it will also become a default feature in the 4G phones.
So, our the satellites what you are going to put in space, further to what you have already working for, they will be having all L1. Right now it is working on L5.
Right. So right now the 4 functioning satellites, as I mentioned, are broadcasting signals in L5 and S bands.
Okay.
These signals will continue. These are civilian signals. They will be having always backward compatibility, so that any device that is currently tracking these signals will continue to do so. In the newer satellites, in addition to the L5 and S bands, we are going to introduce a civilian L1 band.
Okay, sir. We are also, as the theme of this discussion goes on resilient PNT, what kind of security features does the existing thing have, and is it sufficient, or we should go for some more features to be added so that nobody will jam in my area? See, for example, if something happens here, somebody should not transmit some jamming signals. And how vulnerable we are right now, and how do we make ourselves resilient?
This is a very broad question. When we talk of resilience, we can look at it from the perspective of the service provision, that is in this sense, in this case, the space segment or the ground segment, and also from the user, which is the receivers. As far as the space segment, ground segment is concerned, the best approach to provide resilience to the user is to provide multiple signals, multiple services. So that is where the all service providers are progressing towards. That is everybody, while we started with the L5 and S band and GPS had L1 and L2 bands, even now GPS is starting to incorporate L5 band. So they are also moving towards L5 and we are moving towards L1. Same is the case with Galileo. So everybody wants to build in more signals so that in case a specific receiver is getting jammed at a particular frequency, you have frequency diversity. The second is again, as I said, about multi-GNSS. So the receivers are providing multi-GNSS capability, and hence even if one of the signals is getting blocked, the other ones are still receivable. So multiple service providers at the space segment level will provide you that flexibility in terms of resilience. Coming to the receiver side, there are a lot of things that can be done at the receiver level to provide resilience to your PNT reception capability. One of them at a system level is to have, in addition to GNSS, the capability to provide navigation and timing through other means. That is one which is a very broad means. Next is, even if we stick to GNSS itself, there are so many techniques at the system level, like for example having a reference network setup which always provides you reliable signals, or to have a kind of an investigation mechanism around the area which is able to detect such an attempt. Then thirdly, coming down below the system level to a device level, there are so many techniques at the device level which one can incorporate, which I am sure that the innovation hubs will also be looking at. There is a lot of scope for the industry to really contribute in this. A lot of capabilities related to resilience are now coming up as a requirement rather than just as a feature in the devices. So those things need to be looked at. Of course, it's a very technical topic, but broadly speaking, there are a few techniques at the RF level and at the digital level, as well as at the processing level where the position is actually computed. In all these three domains, there is a lot of scope for building in certain features in the device that help you in providing resilience. So at all these three levels, at the system level, at a GNSS equipment level, as well as within the device, there are possibilities and techniques to incorporate resilience.
Yeah, thank you so much. Now, some time ago, 3 or 4 years before, we had conducted a conference on international conference on small satellites somewhere in 2019. One professor from Switzerland has come and he has given a talk. Vaguely, I remember what he was telling. By looking at the phase of the signals which are arriving at a handset and looking at the differences in phase from, say, 3 different satellites. So 3 phase differences I have got. With that, he is constructing a elevation model to the accuracy of 1 millimeter. So that is what he claimed in the paper. I have not cross-checked because neither I was capable of that at that time, nor later on I was interested. Now, do you have any idea, precision technologies or precision positioning if you are doing, do you have any such ideas to make one model which gives me to an extent of level? Because this has got some applications like yesterday what we are seeing. If I can go to snow areas which are covered with snow, the elevation levels when they are changing to the millimeter level, if I am able to detect, I will be able to predict when the avalanche is going to come or when burst is going to take place and things like that. Do you have any idea about this, or do you have any plans to open up this area for research to the industry and or to yourself?
So yes, sir. I think there are a lot of possibilities here based on algorithms, and a lot of developments are happening, especially SAR, synthetic aperture radar. And there's also one mission coming up with NASA and ISRO. I cannot fully tell technically what is, but as a technology innovation hub, yes, we are looking at all the possibilities which are available for funding to develop in remote sensing GIS. We also divide our entire funding into like looking at something on hardware. So there are 3 aspects what we look: hardware, software. Software includes the mathematical modeling, and then the services. Hardware and software. In fact, Hub's major focus now is on hardware part, because as we see, most of the hardware is getting imported. But coming to your point, like accuracy and all, there are algorithms. We have floated some number of projects in these directions. where a number of researchers, industries have come forward to solve some of these problems. Thank you, sir.
Yeah. Yeah, please. Now I think in 2 minutes I will open up for audience for next 5 minutes. But anyway, please.
Yes, sir. Millimeter level changes are possible to observe and map using synthetic aperture radar satellites. Synthetic aperture radar satellites have been flying for last 20 years or more. And there are major players in US, Europe, and India has got RISAT satellites. Differential interferometry, by flying the satellite at the same tube of 500 meters and observing the ground from the same angle, you can create interferometry and identify the millimeter level changes. This has been in use for earthquake measurements, etc. Even millimeter level changes over the mountains will indicate there are likely to be a tectonic activity. So this technology has been already operationally used to map the digital elevation model of the Earth by Airbus satellites. So the TerraSAR X and Tandem X satellites are known for giving that. And several other small satellites are also trying, but the only thing is small satellites fuel is less. If they maintain the tube, their life will go down fast, so they are not offering some of them. So it is possible, differential interferometry. And one thing interesting to notice, I have seen the world's largest use of interferometric technology in China. Beijing has got huge production facilities to map the interferometry. 1/3 of Beijing is sinking because of overexploitation of groundwater. So even Delhi has got that problem. If you really observe it, you'll be able to find, yes, millimeter level changes are possible to observe now. Thank you.
Thank you. But only one doubt I have is I do not know my orbit altitude estimation itself will not be accurate to the extent of millimeters. So I do not know whether it is a change in my orbital position or maybe the earth change or whatever it is. I do not know. One has to do a lot of research in this, especially when we go with the available signals like GPS or any other signals and try to estimate. We are not designing any satellite to find a millimeter level. Of course, interferometry will give. Definitely it will give, I am sure. But if it is from 2 different satellites, it will be much better, or 3. So, yeah. Now, my final thing before I ask audience to ask the questions on the experts, what do you have in this area to offer to the industry, not exactly ready-made, or at least in the future? What do you think, in what way in this field the industry can take up some of the works from ISRO, especially in the event of in space coming up and offering industry all the facilities plus research programs to provide industry? What do you think in your mind in this area ISRO can do?
So, insofar as outreach to the institutions and industries is concerned, one part is the research part, where a lot of academic institutions are already working along with our organization. We have got a very programmatic approach towards this. Our centers float such research programs wherein the professors they become the investigators and they conduct research and basically come out with specific solutions to the problems that have been brought out. The other part is where the industry part comes into picture, and of course, as you know, with the new mechanisms being set up that you just mentioned, the things have become very streamlined for an industry to be able to approach and utilize the resources that have been already set up within the country. In addition to enabling the industry, there are a lot of technical issues that the industries come across. Basically because of lack of expertise or the requirement of a huge resource to be done to solve a certain problem. So we have always been very, very supportive of any industry which approaches us. And in fact, in many of the cases, we have provided them support not only in terms of technical consultation, but also in terms of certain testing requirements if they have. Such kind of a thing is very much possible. In addition to that, there have been a few programs from the other ministries, like DPIIT had conducted a challenge for the startups, where they were funding a few startups for providing a certain solution. So we had proposed them to utilize the NAVIC technology to be incorporated as a part of their challenge. So this was accepted, and last year this challenge was released. So basically the idea here is that an industry may be working, some industry may be working just on PNT, some may be working just on drones, some may be working just on imaging. But when it comes to really commercial utilization, it is the integration of all these three which is also very important. So such a challenge has been brought up by DPIIT, and through such programs we intend to really promote the industry to work in this field.
So one last question to Dr. Roshan. Similar, same question. What do you have to offer to industry? Or you do not have anything, you will do all the research and final product only you will ask them to produce? Or what is your model?
No, sir, it's completely different here. This is a collaboration of industry, academia, stakeholders. So the whole idea of Technology Innovation Hub is to bring industry also on the same platform. We have a huge network of academia, but usually what happens, academicians are doing their research which never get converted into product. Neither industry has a confidence on researchers to take that product or develop the product with the academicians. What we would like to do as a Technology Innovation Hub here is get the problem statements from industry, have the stakeholders meeting, understand where are the gaps. Let's say like PNT. We bring all those industries on one table, including the government agencies, understand where are the white spaces, then work together with the industry. The funding can come jointly from the industry to co-develop the product, or we ourselves can be funding for that product development. So there are a lot of opportunities like that, especially in the innovation sector. We can again have hackathons, joint programs for identifying the startups, funding the startups. So it's the other way around. We become as a Technology Innovation Hub as a facilitator to connect and bring all the industry, academician and other stakeholders onto one platform. So this is what is all about TIH.
Now, I was asked to finish within 25 minutes with 5 minutes of a question and answer session for the public. So now I have done my job of 25 minutes. So 5 minutes is 5 to 10 minutes is left for the audience. Kindly, yeah, please.
So I have two questions. One is for PNT in space, how can magnetism be leveraged? Some people are trying to look at it. And secondly, DRDO system, along with the location, also has the facility of text messages, etc. So they claim, I don't know, they claim that even if a person doesn't have the connectivity, at least messaging can be done in remote locations. So are we looking at combining services like this?
Would you like to have answer or shall I? I will just add one thing and then give it to him because he is the right person to speak on their behalf. We also wanted to have this service. There is something called messaging service available on RNSS thing with a turnaround time of around 10 seconds. So you have to feed something to their control center within 10 seconds. Everybody has, but who has access to decode that only can receive that messages. I think he can add some more on to that.
So when we talk of messaging, what is possible in a navigation satellite is a broadcast message, which is a one-way broadcast. So the source is from the satellite and it goes up to all the receivers within the coverage region. The apparent advantage of navigation satellite being used for this purpose is that navigation satellites are designed for a very broad coverage region. The NAVIC system itself has got any navigation satellite, when it sends a navigation signal, it essentially, the data part is a message. The message is meant basically for aiding in position, but the same message, a part of it could also be provided to provide some sort of an information. In the NAVIC system, the 4 satellites which have become non-functional, 4 are functioning for navigation, the others which have become non-functional have been repurposed for providing one-way messaging. But this has to be done for a social cause. So it has been done to aid the fishermen who are out in the deep seas, so where they do not have any access to terrestrial communication, and especially for providing them safety of life alert messages. And this system is being used by the inquires. But recently, the government of India has come up with a common alert protocol system where the NDMA has initiated this project where they want to have a common protocol for all the messages, be it over the oceans or over the land, and bring a lot of the message dissemination systems on board so that all of them conform to this. So the NAVIC system has been, because everything was in place for NAVIC, it has been identified for immediate implementation, and already the implementation has started. So now this messaging system will be useful over the land regions also. Coming to the other part about magnetism, there are a lot of studies being undertaken right now. Anything that aids in the current means of being able to provide navigation really helps, but it is still at a very nascent stage, and there is a lot of scope for research in this area.
Yeah. Any other questions? Yeah, please. There is one gentleman there.
In proximity to the previous question, so I'm just asking, I hijacked it. My question is to NAVIC, right? It is a good thing that they said that all the mobiles being used in India have to have a NAVIC GPS, which means Qualcomm has already said that, okay, fine, they've incorporated the NAVIC chipset into their chipset, right? My question is a little larger. The synchronization in a network, a critical network, is important. It is based on Stratum 1 clock, which can be derived very easily from a GPS system. Is there a policy that all the critical networks will switch over to NAVIC, because that is more important than your mobile system having a GPS system?
It's a very relevant question. So you have highlighted the fact that while mobile phone is basically for a consumer use, the actual worth of a navigation system for the country is where it gets used in the infrastructure. And time is the most critical part, because ultimately position also is what is derived out of time. So there is a project being undertaken by the Department of Consumer Affairs, wherein they have undertaken the task of providing Indian Standard Time throughout the country through their reference laboratories, because currently the timekeeper of the nation is the National Physical Laboratory at Delhi. But in order to be able to provide time to different portions of the country, since there is a delay and an... Yeah, I was just coming to that. Yeah, so you have...
Stratum 1 clock is important. Either you have a inbuilt Stratum 1 clock, or you have a central clock center, or you have derived it from GPS, which is much better, because that is also using a Stratum 1 clock. Sorry.
Yeah. So that...
Sorry if I interrupted you.
No, that's fine. Thanks for the clarification. The basic standard, the primary reference in the country is at NPL. Now, if you have to derive the clocks throughout the country, as I was saying, there are delays associated with that, which is the basic technical challenge in being able to provide a standard time throughout the country in order to synchronize the entire network. Now, this network could be of the power grid, it could be of telecom, it could be of the financial sector. So you need to provide secondary time sources throughout the country. So that is what the project that the Department of Consumer Affairs has taken up. At the RRSs, they are setting up where the holdover will be done through the clocks, which are the atomic clocks. But at the same time, the time stamping would be done through a GNSS system, a multi-GNSS system, which includes mandatorily the NAVIC system. So that project is currently going on, and it is about 1 or 1.5 years time that it will be getting full-fledged implemented throughout the country.
Yeah. Now one more last question. Yeah. You want to ask?
Yeah, sir.
Yeah, please.
So resilience in PNT is also concerned for GPS, and one of the things that they are working on is the resilient waveform. There is a similar European program, which is the EPW, the European Protected Waveform. Do you think we need, or are we having such a program for ourselves as well?
So there is a part of the signal which is robust in itself, the part of the NAVIC signal which is meant for strategic use. So robustness is something which is beyond resilience. There are a lot of security components in that particular robust signal which only authorized users can utilize, and hence that portion is already built into. Coming to the civilian part of the signal, wherein you want to build resilience as a part of the service provision itself, which I just initially mentioned about, the addition of multiple frequencies, the addition of multiple services within a frequency, but also the possibility of introducing an authentication within the message itself, that a receiver is able to authenticate that this signal is coming from a genuine source. That kind of a feature is being built up into the NAVIC civilian signal also.
Yeah, as promised to you, I have concluded within the time given to me, including question and answers. So I thank the audience, and especially for asking interesting questions and keeping, because I think audience is sure that no tea is being served, they are here. But anyway, thanks to my co-panelists for wonderful discussions, and thank you very much. And I thank SIA to give me this opportunity to sit here and do something. Thank you so much.
So, thank you, esteemed Chair. May I request you to kindly do us the honors of presenting mementos to the esteemed panelists. I request Dr. Sastry to please do us the honors. We thank Shri Manish A. Saxena. Our thanks to Dr. Roshan Srivastav. And now to present a memento to the esteemed Chair, Dr. Sastry, may I invite on stage Dr. Subbarao, President SIA-INDIA. So ladies and gentlemen, before we break, we would like to remind you all that the post-tea session is a very topical session. It will be talking about space security, philosophy, doctrines and strategies, connecting requirements and industrial capabilities. This is a classified section. It will be conducted by Lieutenant General Vinod G. Khandare. So please do join us back in time. We are taking only a quick 20-minute break for tea. This will be a session which will be addressed by the security and strategic companies and experts. So don't forget to join us in time. And yes, before we break, a gentle reminder, in case you are posting on social media, please do not forget to tag us on Twitter, DefSat Conference and Expo, and on LinkedIn, we are Satcom Industry Association. So this is a great opportunity to test those communication satellites. We can check whether they are working properly or not. In case they are not working properly, we can come back and address that issue right here in this room. Meanwhile, tea is being served. It is being served at the RXL area, which is a level down. So please, once again, a gentle reminder, please don't forget to be back. We are going to start the next session sharp at 5. Thank you.
I'm sorry for, this is a very important announcement. The next session is only for the Indian industry and the Indian experts. We would like to excuse people from the foreign companies, and because that's a strategic session. Thank you so much for understanding.